Welcome to the third week of secondary math methods. And this week we're going to be looking at how to create more effective lessons. You are working on your unit plan and your lesson plan, and you may have some ideas here. This is just to help you get some ideas on how to motivate your students. Here's a word of warning. You are probably very happy with your life in mathematics. You probably enjoyed it from kindergarten on up all the way to college, obviously, since you majored in it. And you feel very confident and you liked it all the time. Well, I hate to burst your bubble, but not everyone likes math as much as you do. There will be students in your high school and middle school classes who have no interest at all in what you are teaching. And in your own units, as I've mentioned before to some of you, that you have to think of the big picture. Why do we need to learn this stuff? Maybe you asked that in your class as well, or maybe you asked that in another class outside of math, or in college or somewhere like that. So you want to know why you need to know this. And the pat answer is sometimes you need it for the test, or you need it for future reference, or it'll be good for you in your future. That doesn't always work, because if you ask most adults and you ask them if they can factor an equation, most of them probably don't need to factor an equation and have been very successful. So you have to come up with a better plan on saying it will be for the benefit of them. And I can give you an example. I began teaching a long time ago, at 22 years old, right out of college, and teaching high school students. And I was teaching 16, 17-year-olds in geometry, and they would ask why we had to learn all the SAS, HL, and all the other congruent triangle postulates and theorems. And I really didn't have a good answer for them because I just didn't know. Why are we learning this stuff? Why is it considered important? Why is it part of the curriculum? You have to come up with an answer. And it's just saying that it's on the test doesn't really make it worthwhile for them. So this chapter in this section in this week is about how do you motivate your students? How are you going to get them to really be interested in what they're doing? And students like to be challenged, and students like to be motivated. So they can be motivated if you work hard at it. It takes experience, it takes time. It doesn't always work. Sometimes your best laid plans will fall flat. Well, maybe if you're teaching this lesson to two classes, the first class may be great and the second class not so great. So there's a lot of different factors. But this chapter deals with how to motivate students. I want to remind you that mathematics is the science of patterns. Mathematics is a science of patterns. So if you can get the students to see that there are patterns in life and in their own interests and in their world and outside of the classroom, then you might be able to start there in terms of motivating them. Too often people think, and especially adults, and these are parents and sometimes teachers who think that math is just with numbers. It is more than just with numbers. You can find patterns in art and nature. You probably know about the Fibonacci number, and you can say that, well, if you look at a pine cone and you look at the way it's created, it's a Fibonacci number right there in front of you. So that's just a little example there. So this chapter deals with motivational techniques, and the author talks about what is motivation and gives some ideas on what they should be able to do. So he gives some techniques here, how to motivate students, and they're also here over there. They only have the 9 here, but there are 10 in his book. It's the same author. He's the author of the book. So there's an extrinsic and intrinsic motivation. Extrinsic, are you an extrinsic motivator? Does that mean you're going to give rewards, more points, less homework, food, free time? I tend to want to watch out for this because extrinsic performance is just a reward system that's not based on a student's ability to make a sense of the material. He's really just trying to please you. And extrinsic rewards can also be a double-edged sword. For instance, if you say I will give you points, or I won't give you any homework, then you're almost making homework a punishment in the word. So it's a reward not to do homework. And so if you value homework or value practice work, then don't use that as a means of rewarding them by taking it away. So you have to watch out. Intrinsic, very difficult to get at, but it's much better. You have intrinsic rewards in terms of what you're going to pursue as a career in teaching mathematics. So the intrinsic reward is that you feel that it creates a better understanding for you, and you desire to understand a topic, and you want to outperform others, and so the last goal straddles between Intrinsic and extrinsic. I'm reading this paragraph right here. Okay, so you have to understand that that's what you're trying to get is the intrinsic rewards. So there are different strategies. Call attention to avoiding students' knowledge. That just means that you have to know your students. Get to know your students. I know in this internship you're there just 1 day a week or whatever amount of time that you are, but it's not a full student teaching semester. So you have to get to know your students. That is probably the biggest thing that you can do to help yourself. Get to know your students, then that will help you in terms of preparing your lessons, in terms of teaching your lessons, and it will also diminish your classroom management problems. The first step in classroom management is to get to know your students. Showing a sequential achievement, in other words, the logical sequence is very rewarding to them. Discovering a pattern, and there are many ways to discover a pattern. In the textbook, he gives examples here of discovering patterns, and some of these in finding multiplication patterns and so on. You can see that here. But there are patterns in life. Do you know why we teach the kids in the kindergarten, first grade about the seasons and about the calendar? There's a pattern there. It gets them to think logically. So that's what you want them to do. A sequential achievement such as this is a chart, visual chart in geometry. You have quadrilateral, the family of quadrilaterals, beginning with parallelograms, and you have the sort of stepchild here, the trapezoid, with only two opposite sides parallel, and so on. And then you have the squares, the ultimate parallelogram. So that's a sequential achievement in geometry. But in life, there are so many other sequential achievements that you can use. If you know your students and you know their hobbies, you can connect those hobbies with this particular achievement, sequential achievement. Present a challenge. In Japan, usually they give 1 or 2 problems a day. So try to avoid I will assign 20 problems, odd numbers, because the answers are in the back, and I don't want to have to know what the answers are. And then I'll correct them, and then I'll give them 20 more problems the next day. That's really not math. That's just boredom. And you find that most students will not like that. And those who don't like math, as I see them as adults, will tell you that's exactly what happened to them. That's what it was, just this mindless doing these problems without really understanding them. So present and discover pattern. Present a challenge here. The same thing here with a GWiz mathematical result. And you have other things here that indicate the usefulness of the topic. This is a tough one. Okay, why are we finding this? Why are we doing this problem here? Make sure that's in your lesson plan. Recreational mathematics, there are plenty of them. There are puzzles. I'm going to go here to the site here. There's a whole mess of these puzzles here that you can use that interest students. There are paradoxes or facilities. You can look that up as well. Tell a pertinent story. It's a long pertinent story here. This is a history. If you want to connect history, this is all about building bridges and the history of the Brooklyn Bridge and so on. So there's some geometry and algebra in there as well. Going back here. And then finally get the students to be actively involved in justifying mathematical curiosities. Okay, such as, here we go, the Fibonacci series, the golden ratio, the known as phi. Okay, you can see it. So there's some kind of like cool stuff out there. Pythagorean triples, the 3, 4, 5 triangle, 5, 12, 13, and so on. So perfect squares. Okay, you can see it's active there as well. So you have some different ideas here just to get them motivated. There's a couple of sites, and I'm going to send you these sites here. Is how to motivate students, and a few things here that I'd like to point out. Students who are motivated, if you want them to become like mathematicians, they work for a long time on a single problem. Hey, what a concept. Not 20. So once you get 20, you know what you're doing. Collaborate. Oh, you mean they can talk with each other? Sure, why not? They must prove for themselves that their solutions are correct. Convince themselves. Work on complex problems. Get satisfaction as the intrinsic value, and pride, the intrinsic values, and use unsuccessful attempts as stepping stones. Too often, we don't allow students to make mistakes. We penalize them. Don't penalize your students for making mistakes. If you find that in life, the great inventors, the great discoverers, they made lots of mistakes, and they worked on those mistakes, and they improved. And so did you. You didn't get to this position without making mistakes. And you will as a teacher. Again, I don't want to burst your bubble, but you will be making mistakes and you'll be better for it. And then finally is another article here about defining and motivating struggling math students. And they have some strategies here, motivational strategies, and they also have some suggested strategies as well. So quite a few resources here. I will send that along, and that will be in Blackboard, and hopefully that will give you an idea of how to work some magic with your students. So these are all examples here in the book based on the different types of motivational techniques, story ideas, and get involved in justifying mathematical curiosities. That's what we talked about. So there's a lot of them here. So take a good look at the summary and try to incorporate these motivational techniques in your lesson. I will be looking forward to seeing that. Thanks.